I'm not.
No, you are.
Today's
Next class.
I'm taking
Next
the
class.
sequences is the night.
Oh, yeah. I remember that.
I was just so introduction ceremony.
No.
oh, that should count as one of my classes today.
I just watched an instant classic of intramural basketball.
Okay.
Like two
From
freshman,
yesterday?
sophomore. No, today during advisory.
I don't know, when did the game happen?
Today. Yeah, it was double overtime. It was a comeback, and the final shot was like around the world, like staying up there for like 2 seconds.
Here on campus?
Yeah, here on intramurals.
Oh, intramurals.
Yeah,
Wow.
the intramural league that we have. It was like first day of it today. I keep score on some advisory periods.
That's cool. All right, good morning, guys. If I did not get your assignment 38 last class, I need that from you now. It looks like I got pretty much everybody's, but there's a couple missing. So if that's you, please bring that to me. Okay, we've got our 10.1 through 10.5 quiz next class. So today is our extra practice review time. Make sure you know what you're going to be held accountable for. So I have printed out some extra practice for you. 5 questions from each of these 5 sections. And like I have been warning you about, after we move on from this quiz, we are still going to be using this stuff. So recognizing geometric series, applying the nth term test for divergence, occasionally applying the integral test for convergence. All of that stuff is going to continue to get used. So I give you that warning because I want you to study well to do well on your quiz next class, but I also want you to know it really well so that the rest of Unit 10 doesn't be harder than it has to be. So one thing about this that's a little bit different, again, I just have 5 practice questions from each section. So again, I would always treat this as a practice quiz. Depending on how you do, should tell you which sections or which question types you need to look over between now and Thursday. But I did not just print these out in order. So normally I would do 10.1, then 10.2, then 10.3, then 10.4, then 10.5. I put them in the order that I thought you would think was the easiest. So I put 10.2 first because it's geometric series. Geometric series are typically one of the easier ones. I mean, obviously you might disagree, and then harmonic and p-series is behind that. That's what we did most recently. I think that is some of the easier stuff. And then the nth term test is a little bit harder. The integral test, a little bit harder than that. And then I put 10.1 on the end just because I think that you will think that's the hardest. Not that it's really the hardest, but it has more variety in question types. So it's not in the order that we learned it, but it is in the order that I think it's from easiest to hardest in general for people. So the first couple pages should go pretty quick-ish for you. And then when you get to the back pages, there's a good chance you will have to slow down a bit. Now, of course, please don't set yourself up to, don't overuse a calculator so that you think that you are ready to go and you're not. So for example, number 2, I could probably estimate question 2 by throwing that in my calculator. My calculator doesn't let me put in infinity, but I could put 10,000 there or something and it would be super close to that. So don't use a calculator unless it says calculator active, and then in that case, that's when you should use a calculator. Okay, so any quiz will be 10 questions, 20 points total. Yeah, what else you got?
Is there a calculator on the quiz?
Is there a calculator on the quiz? Like, do I print a calculator on a piece of paper?
Like, Can
I
you use
can-
the calculator on the quiz?
You may not, no. But, like when you work through these, so that means like a question like number 4, I would have to give you something that you could do by hand instead of some weird calculator, because I don't expect you to know what cosine of 1.2 squared is. So I could change that to something you did. There's only one other question on here that says use a calculator, and it's number 1 on the back page, and that's only because the fractions get pretty messy. So again, I would just make it, if I want that type of question on your quiz, and I don't give you a calculator, I would make sure the fractions weren't that bad. But I guess could still test the same thing. And then if I did give you a I know you guys tend to think you want a calculator, but if I give you a calculator, I can give you the exact same questions and then just make you also have to deal with the calculator to get the answer. So that's, using a calculator is usually more work in the long run. Okay, so let me give you some time. Again, I don't think you'll have a million questions here at the start just because of the first couple pages, but again, you should be going pretty quick through the first few and then maybe a little bit slower in the last couple. But these would be the things that are fair game for our quiz next time. And of course, as usual, if you guys are having to glance at something in your notes, or you have to ask me for help, or you're having to ask your neighbor for help on something, that's the type of stuff you should write down somewhere. Give yourself a short and sweet review of the things that you just didn't remember. That would be the stuff that you would want to relearn right before the test, or quiz, whatever.
Is this what r equals on negative e? On this one? 'Cause it's to
That's-
the exponent,
Uh-huh.
so it's that?
Yep. Right. And if you're ever unsure, I would just write out the first 2 or 3 terms, and then it's a little easier to see what's being multiplied. sub n plus 1. A sub n is talking about some term in. A sub n plus 1 would be talking about the next term, because you're adding 1 to n. So what happens when you take a term and divide it by its previous term? That's how you get r. If going this way is multiplying by the same thing, and going this way would be dividing. So that's a long way to say r is, the common ratio is 1/5. Any term you pick divided by its previous term is a different way to say common ratio. You remember the meme about the kids in n plus 1 and n plus 2? First kid, second? Yeah, similar to this.
How do I simplify this? I got part of the way there, but
Here? Okay,
Yes.
so that's a complex fraction, because you've got small fractions within the big fraction. So to make this divided by 9 go away, you want to multiply this by 9. So if you multiply this by 9, everything is multiplied by 9.
including this thing.
Every term. What you're really doing is multiplying the top and the bottom of that fraction by 9 and distributing it in the denominator. So what does that give you? When you do
So
that?
I'd multiply by -9?
You can if you want to. It doesn't matter as long as you multiply everything by the same thing. But at least 9. 9 or -9, but probably 9. Is it hot in here, y'all? No? Yes? Tiebreaker? Tiebreaker?
It's hot.
Oh, that's too slow.
Okay, so once I get to here, the bottom just like reverse, so it'd be like e plus 9.
Mm-hmm. Let's see.
Well, yeah, I'm looking at this thing, so it's e squared minus e.
Okay, so your 9 should be. Oh, I know. I just kept overlooking this again. You didn't do the formula right. It's the first term divided by 1 minus r, not r minus 1.
Oh.
When you switch those two around, then your signs will be okay. Okay. Your first term is wrong. If you plug in 0 for n, all that goes to 1. So your first term is just a. Plug that in for x. And then it's geometric, so you can figure out the first term, you can figure out r, plug it in the formula, and then just because this is weird stuff, you'll have to type it in the calculator to get the answer. Okay, I'm gonna leave the screen on here for a bit, so please call out as you guys get to a question you'd like me to go over on the board. I knocked these small screws down. I thought I was gonna lose them. Sorry. How is the geometric series going? Good. Still no questions on the front page? Okay, has anyone made it to the harmonic and P series have a question? I guess I could also tell you, just for your own knowledge, as we move forward in Unit 10 after this, definitely the two biggest and most important things that you can recognize and know how to work with are geometric and P series / harmonic series. I don't really consider harmonic series a whole separate thing, but P series, geometric series are the most common thing that we've learned in these first 5 sections that will come up all the time. The nth term test also comes up pretty often. The stuff from 10.1 does not come up a lot. And 10.4, the integral test, that stuff comes up the least. But we still need to be able to do it, so. I guess it doesn't really matter to you other than you should try to feel as solid as possible, specifically with geometric and P series. Okay, I'll check back in about, yeah, Brody, you got a question, or you want me to look at yours?
Yeah, number 3 it says 4, it gives the, like, two things, there's only one of them fine, like you only have one.
Yeah, that's a good question. The way I read it, what value of P, is that what you're looking at?
Yeah.
Makes this and this converge? So to me, you should be finding the values of P that make both converge. So I only had the answer to the right.
Yeah, me too.
The one on the left is also true for the geometric because of the absolute value piece, but no, actually you would need both. You would need both of those, now that I think about it, because actually I'm not convinced one way or another. Let me redo it real quick. yes, you would need both. Now that I look at it more carefully. Because both answers work for the left one, and both answers technically work for the right series as well, because the right series, P just has to be less than 4. So that's true for both of the others. So we can go over the whole thing if you decide you want to, but did you have a question, Janie?
No.
Oh, I thought you did. Okay, just checking back in. Did everybody finish the geometric stuff, the front page? So no more questions from the front page? Okay, is anybody still working on the second page, harmonic and P-series? Yes? Okay. Does anybody have a question yet from the harmonic series, P-series page? Okay. For the people who have made it to the nth term test page, is there any of those you want to talk about yet? Okay. We got about 10 minutes till your lunch break, so try to get a handful more done. And again, when we come back, we'll need to finish this. Make sure that you do it in time to get your questions answered. Summarize your strengths and weaknesses so you know what you actually need to review and study, and then I guess you should be good to go.
So one tennis snack I did eat on all of our tennis tournaments were Rice Krispie treats. We were supposed to get one of each and then match. I would take like 30 of them.
You just won every.
I didn't win any matches in the tournament, but I did eat a lot of Rice Krispie treats.
Hey, that's all that. That's all that.
What? I just did you not receive a certificate?
Yeah, guys, I have a second interview, and I'm not even stressed out. Yeah. The interview's so good. The thing is, like, really truly, basically our job, like, I'm doing the second interview, then have to, like, not do the job.
Right. Yeah.
So then, it's like, happens sometimes too. I think
Me and River were both doing it.
Oh, that's fun.
We won't know.
So Ava, what I'm hearing is that you just kind of guess on how
No,
to.
I didn't just guess. It's like, I thought really.
So you got n plus.
A squared plus. Sorry, plus 1.
I was like,
Yeah, what was it?
Oh, yeah, so.
you just thought really hard.
Yeah, it was like.
Well, yeah, well, 3 on the top makes a difference. Yeah, 3 on the top makes a difference. So you just thought really hard.
Well, it's not multiplying by anything. So, none of those are like
And
the
then I was
square
like,
root
the
of
whole
something.
rest of this.
Or something squared or whatever. So I was like, it has to be.
Did he like sound like he knew what he was talking about?
And I was like, it was
Poor
plus
guy.
1, and then
He's
it
trying.
had to be 1 squared, and then 2 squared plus 1, and then 3 squared plus 1.
So you just look for the relationship and how you got into those,
Yeah.
basically. Okay.
This is what I mean. Like this one.
And I just plugged one in.
What? I don't know. Like, I plugged in equals 1 into. Like, I just made all of them into 1. I don't even know how that works.
I don't know how it works, but
I
it's
skipped
the
that
same
one.
answer, so I think I did.
I started because I was just.
This one, like this one? This one? Number 5? Is that on the... You just plug in... Oh, this one? I know what that one is. It's a thing where we kind of ignore like the plus 1 because it would just be a big difference. And I separated the 6 items apart, so I get 6 m plus 6 m plus 1, and then those like cancel out.
All right, guys, how can I help? Everybody said they were good with geometric. Did anybody find anything on harmonic and p-series page? Nth term test for divergent page. Okay, how about integral test for convergence? Has anyone gotten there? Number 2. Okay, so this is a very common one. Again, you do not have to jump ahead to this one if you're not there yet, but this is a common question, so you may want to. I do have it worked out on the class website as a video, though, if you decide you need help with it later. Okay, so first off, confirm that the integral test can be applied. So just as important as knowing what the integral test says is to know when to use it. So it has to be continuous. And if I look at these terms, it doesn't look like there's any reason to believe this would ever be division by 0. It needs to be positive over the long run. So if it's negative at first, it's not a big deal, but positive, 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 I can assume that they're all positive. And what's the other one? Positive, continuous, and decreasing. So 2 or 3/2, 3/5, 3/10, that's definitely decreasing. So there's the showing that I can use the integral test if I want to. To be honest, I try to avoid it because this one is more tedious than a lot of the others. This is kind of the last resort in my opinion. But what the integral test says is that if we if we take this infinite sum, which they did not provide to us, so we will have to make up the sequence so that if n is 1, we get this term, but if n is 2, we get this term, and if 3 is this term. So we're going to have to figure out what that sequence is, and then we're going to change this from an infinite sum question into a integration question. And if the integral converges, then the infinite series converges. If the integral diverges, then the infinite series diverges. So, well, first off, the numerator always stays 3, so 3. So what kind of formula would I need? So if n was 1, I got 2, but if n was 2, I get 5, and n is 3, I get 10. What would the denominator need to be?
I was thinking 1 plus n squared.
Okay. 1 plus n squared or n squared plus 1, whichever, same thing. So 3 over n squared plus 1 is what you would need to integrate. So did you make it this far? Okay. I'm going to suggest with a big asterisk here, because I redid this a day or two ago, and this 3 is just a number, 3 is a constant, so a lot of times we put the constant in front of the integration and or in front of the limit. So I did that, and then I kept up with it for a few steps, and then I forgot it at the end. So if you do pull the 3 out front, make sure you don't lose it. Okay, and then of course the limit is going to be there till the end, and then there's 2 pretty challenging things about this question that makes this one very commonly asked. What is the antiderivative of 1 over something squared plus 1? Usually it's 1 over x squared plus 1, but in this case it's n squared plus 1.
Inverse tangent.
That is one of 2 inverse trig functions you're supposed to know. Inverse tangent's a derivative, or integration you need to recognize, and inverse sine. You don't have to know the others, but those 2 you have to recognize. So I'm going to guess that's the first place you got stuck. You didn't recognize that? Okay. Okay, but it's still not an easy question. Well, it really depends on if you did pre-calculus or not. Even if you did pre-calculus, it's going to be pretty tough. But so we're going to plug in b the first time, plug in 1 the next time, subtract those. So our answer is going to come from 3 times the limit as b goes to infinity. And actually, let me just do those steps here. What is the inverse tangent of 1? So that's asking what angle gives you a tangent value of 1?
Pi over 4.
Okay, and why is it pi over 4?
Because square root of 2 divided by 2 divided by square root of 3 over 2 is 1.
Right, at pi over 4, sine and cosine are the same, tangent sine divided by cosine. That one's a little easier to see. This one's a little bit harder, and again, this is where I say, and those of you that did pre-cal have a little bit of an advantage here. If I try to take the limit as b goes to infinity, I'm trying to figure out what angle has a tangent that approaches infinity. So I think the only easy way to do this is to know what the graph looks like. So the graph of tangent, and of course you could just make a table and kind of figure out what it looks like. But if you did pre-calculus, you memorized this at one point, so that's going to be a little bit easier. But at 0, we get 0. At pi over 4, we get 1. Anyway, it looks like this. So this angle right here, where the tangent value is approaching infinity, is what I want to put in place here. Because inverse tangent of infinity, what angle gives me a tangent of infinity? So, do you know what angle that would be? Think of tangent as sine over cosine. If tangent is sine over cosine and I want it to be as big as possible, do I want sine to be big or small? Okay, it was 50-50. And everybody missed it because nobody guessed. If tangent is sine over cosine, if I want this to go to infinity, I want this to go to infinity. So do I want the numerator to be big or small if I want the whole fraction to be big?
Small. Wait, is the numerator the top one or the bottom one?
It's the top one.
Oh, I want it to be big.
Okay, we want this to be big, right? Well, think about the unit circle. When is sine the biggest? At pi over 2. Okay, and if I want my fraction to be as big as possible, do I want the denominator to be as big as possible or as small as possible? Small. The smaller a denominator is, the bigger your fraction is. And where on the unit circle is cosine as small as, well, ignoring signs, we don't want negative stuff. But cosine approaches 0 at pi over 2. And if you're dividing by something that's close to 0, it makes your fraction go to infinity. If your numerator keeps growing, then your whole fraction goes to infinity. So all of that is to figure out that this was pi over 2. Now again, if you remember what the tangent graph looks like from pre-calculus, that's a lot easier to figure out. But pi over 2 minus pi over 4 would be pi over 4 times 3 is where they get 3 pi over 4 is the final answer. Okay, so there's a lot going on there. Olivia, is that good enough for now, or do you want something else? Okay. I know several other people would have asked about this one at some point, so again, there's several different hurdles in this question that makes it tougher than the rest, but is there anything else you guys want to ask as a follow-up? Okay. All right, let me give you, I don't know, say 10 or 15 minutes here, and then we'll see what else you find. know what you're looking at?
Yes, number 2.
Okay, so the nth partial sum. Okay, so you started writing out the first couple terms, but instead of putting commas, put plus signs, because this sums them all up. So that, if you keep going until you go to 1/5n, so if you say plus dot 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 1/5n, that's what this is equal to. So you need to put this equal to all of that stuff. Okay, and then what you're going to do is, sometimes we did half of the s of n, but in this case you want this to actually shift over here. So do another line and take s of n divided by 5, or 1/5 s of n. So you're dividing that side by 5, and you're going to divide everything on the right side by 5. So you're going to start off with 1/5 squared, and then 1/5 cubed, and then dot 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 1/5 to the n, and then go one more, 1/5 to the n plus 1. Okay, so this is what it's asking for when it says the nth partial sum. The problem is we don't want this. We don't want this infinite thing. But when you know what this is equal to, and you know what a fifth of this is equal to, now in this next line you can take this minus this on one side. And when you take all of this stuff and subtract all of this stuff, this cancels out this cancels out this, those all cancel, and you're only left with the 1/5 minus this very last term. So go ahead and write that down.
So then where does the 1/4 come from? It's supposed to be 1/4.
Don't worry about the 1/4. You're not there yet.
Okay.
So what is this equal to? This is equal to what? How did we come up with that?
Just the nth partial sum, no? Like,
We took all of this minus all of this. So your other side is s of n minus
so
1/5
like
s of n.
4/5.
4/5 s of n, Now if you multiply both sides by 5 and divide both sides by 4, you'll get your answer. And then that's where the 4 comes in, the 1/4. So you got to make yourself write out the infinite series, and then to get this to shift, since this was a fifth, I divided this by 5 and then divided all these by 5. That way when you take all of this minus all of this, basically everything cancels out, and then you can just multiply by 5/4 on both sides, and then you get the answer this you want.
Okay. Thank you.
Uh-huh. what else have you found?
Number 2 on 10.3.
Number 2 on 10.3, okay. Okay, this one says, use the nth term test for divergence to determine if the series diverges. Now, to be fair, these directions are not great based on what they're going to expect out of you here. So, basically the nth term test for divergence is where we take the limit as n goes to infinity of a sub n and if it does not equal 0, we know it diverges, and if it equals 0, then we learn nothing. It's inconclusive. There's a lot of times the nth term test is just not that useful. So this is a hard limit to work with because it's hard to see what's going on here. So in several of these questions, a good strategy is if this is pi to the n plus 1, split that up. Call it pi to the n times pi to the first. When you multiply things with the same base, you add the exponents. You're just used to going this direction, but you might also want to split it up into this direction. So this pi could come out front. I don't really care about it. That's just a number. And then both of these are to the power of n, so I could combine them, and I'm going to just pull this pi out front. So pi over 7 to the n power. So the problem here is if I take this limit, this is a harder limit to figure out what it goes to. Does pi to the n grow faster, or does 7 to the n grow faster?
It would be 7 to the n.
So we get pi times all of this would just be 0 then, right?
Yeah.
If your denominator is growing faster than your numerator, then your fractions head into 0. So the nth term test for divergence comes inconclusive. Now here's where I said the directions are my favorite, because they shouldn't say just use the nth term test. They should say start with the nth term test. If the nth term test doesn't work, you've got to find another way to do this. You can't just do the nth term test on every one of these questions in chapter 10. So what I noticed though is within my work right here, this is geometric. If I rewrite it this way, if I've got pi over 7 to the n, as n gets bigger, I'm multiplying by more pi over 7s. So pi over 7 is the common ratio. It's geometric. The absolute value of pi over 7, would that be less than or greater than 1?
It would be less than 1.
Okay, and then in geometric, when the absolute value of r is less than 1, it converges. So the nth term test was just a waste of time, unfortunately. But when it does tell you something diverges, it's usually very efficient. Especially if it's like one of these from 10.4. I'd much rather do this, see that it diverges, versus having to do all the integration to figure out that it diverges. But each of these have their limitations. Okay, anything else about 2? Then what else have you found? Okay, well we still got close to 20 minutes, so let me give you about 10 more minutes, and then that will leave me about 10 minutes to try to take some more questions from you. Again, quite a few of these are worked out on the website, so I know some of you are already finished, but if you don't finish in class and you see that you need some help with one, more than likely it'll be on the website, so try to use that, please. No, I want you to keep it until next time. If I take it from you now and I don't grade it and get it back to you fast enough, then you don't have it to study. Got about 10 minutes left, so if you want to get me to help out with a few more questions, time is running out. I do not want you to turn it in today. I will have you turn it in before we start the quiz on Thursday.
Landon, does anybody record those basketball games?
No.
It's too bad.
Did you see Wimby's dagger 3 last night?
I did not.
Walk on one in, and then 4-3 on the other.
Is it better than the 3 he had after the 2 blocks the first game of the season?
I'd say so because it was like a clutch situation. It was a dagger that he blocked a chance to like get close and then put it out of reach on the other side against the Bulls.
I have not been following too much. I watch all the Warrior games, but after they had a good start and then they kind of started to slump in a little bit, I've tuned out a little bit. But I think the Spurs are going to be scary. I think Fox was too good of a pickup to match up with Wemby, but let's see where everybody's at. Okay, we have about 3 minutes here, so of course I will ask you to turn this in next class so I can give you some class points for doing that. Make sure you've got it complete. While all this is fresh in your head, it would be a great idea to mark some of the questions or mark some of the things that you hadn't remembered. That's the stuff that's worth your time to review. And if I remember right, several of these questions come straight from some of your practice. So I only remind you of that. That's not always the case, but I remind you of that because if geometric is your weakness, these 5 questions are just helping you identify your weakness. They're not helping to solve the problem. You should still go look when we did the geometric worksheet and look through it to make sure that you're good with that topic.